It took 15 years of imaging and nearly 3 years of stitching the pieces together to create the largest image ever made, the 8 trillion pixel mosaic of Mars' surface. Now, the first study to utilize the image in its entirety provides unprecedented insight into the ancient river systems that once covered the expansive plains in the planet's southern hemisphere. These 3-billion-year-old sedimentary rocks, like those in Earth's geologic record, could prove valuable targets for future exploration of past climates and tectonics on Mars. The work, published this month in Geology, complements existing research into Mars' hydrologic history by mapping ancient fluvial, river, ridges, which are essentially the inverse of a riverbed. If you have a river channel, that's the erosion part of a river. So, by definition, there aren't any deposits there for you to study, Dickson, lead author on the paper, explains. You have rivers eroding rocks, so where did those rocks go? These ridges are the other half of the puzzle. Using the mosaic, as opposed to more localized imagery, let the researchers solve that puzzle on a global scale. Mars used to be a wet world, as evidenced by rock records of lakes, rivers, and glaciers. The river ridges were formed between 4 and 3 billion years ago, when large, flat-lying rivers deposited sediments in their channels, rather than only having the water cut away at the surface. Similar systems today can be found in places like southern Utah and Death Valley in the U.S., and the Atacama Desert in Chile. Over time, sediment built up in the channels. Once the water dried up, those ridges were all that was left of some rivers. The ridges are present only in the southern hemisphere, where some of Mars' oldest and most rugged terrain is, but this pattern is likely a preservation artifact. These ridges probably used to be all over the entire planet, but subsequent processes have buried them or eroded them away, Dickson says. The northern hemisphere is very smooth because it's been resurfaced, primarily by lava flows. Additionally, the southern highlands are some of the flattest surfaces in the solar system, says Woodward Fisher, who was involved in this work. That exceptional flatness made for good sedimentary deposition, allowing the creation of the records being studied today. Whether or not a region has fluvial ridges is a basic observation that wasn't possible until this high-resolution image of the planet's surface was assembled. Each of the 8 trillion pixels represents 5 to 6 square meters, and coverage is nearly 100%, thanks to the spectacular engineering of NASA's context camera that has allowed it to operate continuously for well over a decade. An earlier attempt to map these ridges was published in 2007 by Rebecca Williams, a co-author on the new study, but that work was limited by imagery coverage and quality. The first inventory of fluvial ridges using meter-scale images was conducted on data acquired between 1997 and 2006, Williams says. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.